So looking at the calendar, you should have done the video module plus the ticket in the door and turned that in for today's class. We're on August 30th, so that was today, what was due today. Reminder, there is no class on next Monday, so the next time we'll see you after today will be next Wednesday, which ticket in the door 5.1 will be due for our next class meeting. For today, I'm going to kind of recap the video module that you watched and learned about. So if you can get a piece of paper out, or if you want to write on like the back of the, if you have a back of the flaws of apportionment in-class activity sheet, we're just going to write down some stuff as kind of a recap of what these flaws are when we do apportionment using specifically Hamilton's method. So let's take some notes here just so we have something to look at when we're working on figuring out which paradox each situation is going to represent in the worksheet. So 6.3, flaws of apportionment. And these have to do with Hamilton's method of apportionment. There were three types, so we'll kind of talk through all three of them and identify what the tells are for each one. First one we're going to define is the Alabama paradox. Who can tell me what the Alabama paradox, or like summarize what it is? Or the general idea of it? If you remember from the video, or if you took some notes.
It's when you're adding a seat to the total and then one of the other states loses one even though the population didn't change.
Good. So key characteristic is from one year to the next. All that changes in like the situation is that one seat is added to the total number of seats. So imagine your situation where there's three cities and they have some seats in some kind of Congress situation, right? And there's a total of, I don't know, 10 seats this year, and those 10 seats are distributed to the cities. Next year, they decide that we're going to have 11 seats, right? So we just add one seat to that Congress, that group of people, that committee, and what you would expect to happen is that that new seat would just go to one of the three cities or whatever the groups are, and there would be no other change. One of the cities would just gain a seat, right? But what happens sometimes because of the way the calculations are done doing Hamilton's with the rounding up and the rounding down is that a state loses a seat. So not only does the new seat get added to one of the states, but also one of the other states will lose a seat to one of the other states. So, which you can hopefully understand why that's an issue, because adding a seat to the total number of seats should just increase one of the state's seats by one, and it shouldn't really affect anyone else. No one should be losing a seat in that situation. So if there's a loss of seat as a result of adding a single seat to the total number of seats, that's going to be what is called the Alabama paradox. Second paradox we have is the new states paradox, or the new state paradox. Okay, who can anyone give me the characteristics of a new state paradox?
The new state paradox is when we have one more state, and then we also add 2 seats, causing one of the order states to gain a seat and then one to lose a seat.
Okay, good. Not necessarily 2 seats. It depends on what the new state is, but that's perfect. So from 1 year to the next, a new state or states, we could just put that S in parentheses, new states and new seats are added. New seats for the new states are added. And what should happen is that once you add a new state and you add the number of seats that are going to go to that new state, the other state's seats should not change. Right? If we introduce a new state and we know that they're going to get 3 seats, and we increase the number of seats by 3, and that new state does get those 3 seats, then it doesn't make sense that the other states involved in this whole thing should shift in their number of seats. But what happens sometimes is that a state loses a seat to another state. So a state that is not involved in the new state situation loses a seat, which is a problem. So that's the paradox there. Okay, and then finally, what's the third paradox we have?
Population paradox.
Thank you. And can you tell me a little bit about the population paradox?
It's like when one state has a significant increase of population compared to another, but then they lose more seats than the other one.
Good. From 1 year to the next, populations change. That's not a problem, right? That's just something that happens in the real world. But what the problem is that a state that grows faster loses a seat to a state that grows slower. I'm going to put in parentheses here, you're going to have to compare growth rates to actually identify whether a population paradox is happening or not. Compare growth rates. And the growth rate kind of depends on what the population was to begin with, right? It's not just this state's population grew by 10,000 people, this state's population grew by 20,000 people. That doesn't really mean anything unless you know what their old population was, right? It's when we talk about growth rate, we're talking about a percentage growth rate. So let's write down a formula for population growth. Somebody's unmuted. Who's unmuted? We fix it? We fixed it. Okay, good. Population growth percentage. We can compute by doing a calculation here as a fraction. We could do new population minus old population, and then divide by the old population. And finally get that result and multiply it by 100 to put it into percent form. Right, because when you do that division, you'll get a decimal number, which is the growth rate. But if you want it in percent form, you got to multiply it by 100 there. So again, key identifying factors we're looking for in these examples. Or I guess I should talk about the examples. There are 3 examples. Example 1. Every example is going to show you 2 different years. So 2021, you're going to calculate seat distribution from 2021 to 2022 for these 3 schools. And you're going to do the same thing for 2022. And then from the tables, from what happened, whether the population's increased or the seats increased, whatever the situation was, you're going to figure out which one of the 3 paradoxes did occur here, or maybe none of them did, right? So maybe it looks like it could have been Alabama paradox, but it didn't actually happen. So you're tasked with identifying which school would be unhappy at the end of the situation, and then name the paradox associated with this example scenario. And then we're going to go to the next one, which again, you're going to go from 2021 to 2022. You're going to calculate the seats that each school would get in this specific situation. And then you're going to answer which school would be unhappy and name the paradox that is the name for this issue. And then we're going to do it again. There's a correction on example 3. So if you have this printed out, please correct this. This should be 143, not 100. On example 3 at the very bottom, the last number on the page, the number of specialists should be 143. If you don't fix that, then it's not going to look good. So make sure you fix that so that the numbers work out right. Again, we're going from 2021 to 2022, so 1 year difference, and things are changing. And you just got to figure out which school is unhappy and name the paradox that's associated with this situation. What was I going to say? So to recap things you're looking for to identify the paradox. One of the easiest ones to identify is the new states paradox. If you introduce a new state or a new school from 1 year to another, so the population of a school goes from 0 to something, that's essentially a new state or a new school, right? So you got to figure out if there was an issue, if a state or a school did lose a seat as a result of that new state being added to the situation. So that's one of the easiest ones to identify. The next easy one to identify is the Alabama paradox, because it specifically talks about a single seat increase from 1 year to the next, right? In the examples here, we're talking about specialists instead of seats. That's what the seats are in the examples. So if there's an increase of a single seat from 1 year to the next, or a single specialist from 1 year to the next, it's probably the Alabama paradox. Now you still need to figure out if one of the schools is unhappy, because normally when you add a seat or you add a specialist, you're not always going to have an Alabama paradox, right? This is just something that happens when the numbers are in a very particular situation where a state does lose a seat, so that they would be unhappy, right? But usually when you add a seat, that new seat would just go to one of the 3 states and everyone would be fine with it. The issue is when a state loses a seat as a result of that seat being added. So don't automatically think it's Alabama paradox just because a seat was added. If you find that one of the schools would be unhappy or one of the states would be unhappy because they lost the seat, then you have an Alabama paradox. And then finally, the third paradox is the population paradox. This is easily identifiable with population changes from one year to the next, right? If all three populations are going up and down, then you're probably in some kind of population paradox question as far as the questions are concerned. For the Alabama paradox, where one seat is added, there should not be any changes to the populations. So you'll never see a situation where like populations change and exactly one seat is added. That's a very particular situation. So then you could have a mixture of like Alabama and population paradox. We're looking at them in very isolated cases where just a single seat is added and nothing else is changed, right? Or the populations are changing and we're not changing anything else about the number of seats or anything like that. Or in the new states paradox, we're looking at a new state being added and the seats for that new state being added, but the populations of the other states are not changing, right? So we're looking at these in very particular isolated cases. And these examples are built in a way that they are very isolated particular cases. So are there any questions on like these three